Hi everyone, welcome to this video where you will learn about AWS cloud architecting concepts and few best practices. In this video, we will start discussing the traditional infrastructure, what are the challenges that are associated with the traditional infrastructure and how they can be solved when we move our architecture on AWS. We will also learn about the well-architected framework and all the 5 pillars of well-architected framework. Then we will see what is well-architected tool and what is trusted advisor, how they can help the architects on AWS, and then the best practices that we need to follow when we are designing the architectures on AWS. My name is Aishwarya Sood. I am a software engineer and AWS trainer by profession. I am 3x AWS certified, also an AWS Academy accredited educator. You can connect with me on LinkedIn. My profile name is given here, Aishwarya Sood 29. You can also scan this QR code to view my profile. So let's begin with this video with our first topic, that is traditional infrastructure. Cloud computing quite differs from a traditional, or you can say on-premises environment in many ways, including the flexibility, global reach and scalable capacity, managed services, built-in security, options for cost optimization and various operating models. So here you can see few things about the traditional infrastructure. Here's a server. Here's how they are connected to each other, how like wired connections will be there for all the servers, and this is how they look like inside when they are in the data center, and this is how the data centers look from outside. But what are the few facts and challenges that are associated to such a infrastructure? Let me tell you. First of all, it is fully managed and owned by the business within their own facilities. Okay, wherever your office is located or wherever your school, bank or hospital is there, within the premises this kind of data center will be there. And the few challenges that are there with such kind of infrastructure is that of course we are managing and owning the hardware, so it requires a lot of space, it requires a lot of admin staff to take care of, and physical security, of course the software security as well, cooling equipment, planning, capital expenditure and a lot more things. Company will have full control over the security and the management, but there are some challenges that are one I told you. Okay, and others are like resources may be overutilized or maybe underutilized in actual, because we will be just guessing the capacity that based on our guess we will be purchasing that much of capacity for all the hardware, but it might be overutilized or underutilized. Also, it is not flexible. There will be a lot of heavy lifting tasks and maintenance charges, and that's why it is very expensive. Not all the companies and especially the startups cannot afford such data centers. They require high level continuous power and connectivity. There are long procurement cycles, like when we need some resources and when we actually get those resources, there will be a lot of time between that, like few days to few weeks. So that's why we prefer moving to the cloud. And let's see how the infrastructure looks like in the cloud. Few things we will be seeing about the architecture on AWS. So first point is that the cloud computing lets you use your infrastructure as a software, because all the things are available over the internet for your use. You are not going to own and manage the data centers anymore. All the services will be available to you as a web service in the form of a software over the internet. They are flexible. We can get the resources when we want and we can delete them when we do not want them. It is not like a very hard or a fixed structure. It's completely flexible. They can change more quickly, easily and cost effectively than the hardware solutions. Okay, we want to change some configurations, we want to add more resources, we can get them quickly. They are highly cost effective than the hardware solutions. There are a lot of cost savings if you compare the cost of cloud computing architectures and the cost of traditional infrastructure. You will get to know the huge difference is there in the cost thing. Okay, on cloud computing it will be highly cost effective. Also, it eliminates the need for undifferentiated heavy lifting tasks, like we won't be owning and managing the hardware. That's why There won't be any heavy lifting tasks at our end, and the procurement cycles are also small. It is just like that minutes between wanting and having the resources. Whatever we want servers, we want databases, just navigate to that particular resource, click on launch, configure it, and the resource is yours. This is the cloud computing. But just think about the procurement cycle on the traditional infrastructure. You want the resources, then you have the resources. Actually, there will be few days to few weeks between that. Okay, so that's the architecture on AWS. Now there are a lot of concepts which you need to know when you start architecting the solutions on AWS. Few of them I have included in this slide. Let's look into them one by one. Like the first concept that comes here is continuous integration, which is just the automation that is used to perform the builds of software and automates the tests against that software. Then comes the event. It is nothing but a instance of something that is happening that is significant to the workload, some kind of change that is happening in your environment. Then we have is the federated identity, which are those which enable the users to have single identity stored in an organization's central identity provider. Then we have edge location, which is a site that the CloudFront uses to cache the copies of your content for faster delivery to users at any location. Then we have data warehouse, which is a central repository of information that can be analyzed to make better informed decision. Then we have cost allocation tag, which we can use to organize our resources cost on the cost allocation report. Next is the best practice, which is a kind of a proven way of achieving successful outcomes. Then next we have a CloudTrail, which is a service in AWS which is used for recording all the API calls. Then comes the resiliency, which is the ability of a workload to recover from any kind of infrastructure or service disruptions. Then we have a playbook, which is a documented process to investigate the source of an issue. Next we have is latency, which is a measurement of the amount of time between an action and the result, often between a request and a response. And in memory means the state of being stored in temporary memory like RAM rather than on a stable storage like the disks. And game day means that we can simulate a failure or event to test the system's processes and team's responses. Okay, just a kind of like we are simulating the failure and we will see what happens exactly based on whatever we have implemented, and we will get to know how this can be optimized to a better way. Then VPC flow logs are the ones which enable you to capture the information about the IP traffic going to and from the network interfaces in your VPC. And workload, it means the set of components that together deliver the business value. Then scalability means a measurement of a system's ability to grow to accommodate an increase in the demand. These are just few concepts that I have told you. Apart from this, there are a lot more concepts also. If you want to read more about these concepts and even more concepts, we will be giving a link in the description of this video, so you can go through them once. And then next topic comes the AWS well-architected framework. This is a guide that is designed to help you build the most secure, high-performing, resilient, and efficient infrastructure possible for your cloud applications and workloads. It will provide a consistent approach to evaluate cloud architectures and guidance to help implement the designs. It documents a set of foundational questions which you will answer while designing an architecture, and best practices that enable you to understand if a specific architecture aligns well with the cloud best practices. AWS developed this framework, that is a well-architected framework, after reviewing thousands of customer architectures on AWS. So this framework is divided into 5 pillars, which you can see: operational excellence, security, reliability, performance efficiency, and cost optimization. So we will discuss all of these pillars one by one and the design principles that are included in each of them. First pillar that comes here is operational excellence. This pillar focuses on running and monitoring the systems to deliver the business value and continually improving processes and procedures. Key topics in this will include the automating the changes, responding to events, and defining standards to manage daily operations. Basically, what happens is, let's say I have designed my architecture based on all the best practices. My architecture should be able to stay up to date with the latest best practices, and it should be able to accommodate all the changes and still deliver the business value in the expected way. It should not be like that I have applied some changes and it has been disturbed. The entire architecture is now not working well. So the design principles that are included in this pillar is, first is perform operations as code, which says define your entire workload and all the applications and the infrastructure as code, and also update it with code, like the concept of infrastructure as a code, which we perform with the help of AWS CloudFormation. Then it says make frequent but small and reversible changes. The changes that you are implementing in your infrastructure, they should not be big changes, they should not be infrequent, they should not be the changes which you can't roll back. They should be frequent but small and reversible changes, so that even if you don't like the change, you can roll back to the previous state. Then refine operation procedures frequently. Look for opportunities that you can use to improve the operation procedures. Evolve your procedures appropriately as your workloads evolve based on the latest changes. Anticipate failure. Identify any potential sources of failure so that they can be removed or mitigated on time itself, and learn from all the operational events and failures. Drive the improvement through lessons learned from all the operational events and the failures. Share what is learned across teams and through the entire organization so that they can be mitigated for the future times. Next pillar is reliability. This pillar focuses on ensuring that a workload performs its intended function correctly and consistently when it is expected to. A resilient workload quickly recovers from any failures to meet business and customer demand, and the key topics that are included here is distributed system design, recovery planning, and how to handle the change. The design principles that it includes is, first is that automatically recover from the failure. You should monitor your system for key performance indicators and configure your system to trigger an automated recovery when a threshold is breached. It should not be like that some failure is happening or a threshold is breaching. You are manually recovering from that, or you are manually performing the actions. It should all be automated. Then it says test the recovery procedures. So you would have implemented some recovery strategies, some disaster recovery strategies. Test how they are working. Simulate some kind of failure and see how they are responding in the time of a failure. Do not wait for the actual failure event to happen and then see how they are happening. Simulate the failure and see how they are working. Are they working as expected or not? So if you can get to know that if they are not working as expected, you can improve them. And then it says scale horizontally to increase the workload availability. Instead of scaling vertically, scale horizontally so that the number of resources will be increased and the workload availability will also be the aggregated resource capacity will be increased so as the workload availability. Also, stop guessing the capacity. The days are gone when we were just guessing the capacity that how much resources will I require for my architecture. No, these days when you have moved to the cloud, you don't have to guess the capacity for how much resources you will require. Just get the resources based on the actual workload patterns and manage the change in automation. Again, use automation to make changes to your infrastructure and manage all the changes in automation instead of doing them manually. Next pillar that we have is performance efficiency. This pillar focuses on using IT and computing resources efficiently. Key topics will include selecting the right resource types and sizes based on the workload requirements, monitoring the performance and making informed decisions to maintain efficiency as business needs evolve. And the design principles include democratized advanced technologies, which means consume the technologies as a service. For example, technologies such as NoSQL databases, media transcoding, and machine learning require some kind of expertise that is not evenly dispersed across the technical community. In the cloud, these technologies become services that teams can consume, and consuming technologies enables the team to focus on product development instead of resource provisioning and management. Also, go global in minutes. Deploy the systems in multiple AWS regions to provide lower latency and a better customer experience at minimal cost. Use serverless architectures. Serverless architectures will remove the operational burden of running and maintaining servers to carry out any traditional compute activities, and they are better. So go for, like, whenever and wherever possible, go for serverless architectures. Also experiment more often. Don't stick to some one technology or one practice. Keep experimenting, perform comparative testing of different types of instances, storage or configurations, and see what suits you the best. Also consider mechanical sympathy. Use a technology approach that aligns best to what you are trying to achieve. And next pillar that we have here is security. This pillar focuses on protecting information and systems. The key topics here will include the confidentiality and integrity of data, identifying and managing who can do what with the privilege management, protecting the systems, and establishing controls to detect security and events. So the design principles that are included here is, first is implement a strong identity foundation. So implement the principle of least privilege and enforce the separation of duties with appropriate authorization for each interaction with your AWS resources. Okay, only grant the permissions that are genuinely required by somebody. Also enable the traceability. Monitor, alert, and audit the actions and changes that are happening to your environment in real time. Apply security at all the layers of your infrastructure, whether it is compute layer, storage layer, database layer, whatever it is. Make sure the security is applied at all the layers. Also, automate security best practices to improve your the ability to securely scale more rapidly and cost effectively. Also, protect the data in transit and at rest. Classify your data into sensitivity levels and then use the mechanisms such as encryption, tokenization, and access control wherever appropriate. Then comes a pillar of cost optimization. This pillar focuses, as the name suggests, on focuses on avoiding unnecessary costs. So cost optimization is an ongoing requirement of any good architectural design. The design principles include mere efficiency. So you should be knowing that what is the best type of resource that serves my purpose, what is the best size of it, so that you are using all the resources efficiently and there should be no compromise with the business value. Also eliminate any unneeded expense. Okay, and consider using managed services. So wherever possible, whenever possible, go for managed services so that the operational overhead is reduced and the cost is also reduced. And they make sure any stale snapshots or any unused resources, anything that is remaining idle in your account which you do not need, make sure you are deleting them on time so as to save the costs. In short, always look for the ways to optimize the costs. Okay, so now we will discuss the best practices that you need to follow when architecting the solutions on AWS. There will be quite less hands-on in this session because of this is a theoretical concept which you need to understand, but there is no specific service that we will be learning. Only two things will be there for which we will be seeing some basic hands-on: the well-architected tool and trusted advisor. Rest of the things you have to understand theoretically and you have to implement when you are designing the architecture on AWS. So the first best practice comes here is scalability. First, look at this anti-pattern. Here what is happening, there is no scalability. These are your application servers which have reached the full capacity and users cannot access the application. Here what administrator is doing, he is manually launching new server, and new server will take some time to launch, maybe few seconds to few minutes depending on the configuration. This is manually happening. Okay, no automation, no scalability for the automatic. Okay, and here you can see it is the scalability is implemented through auto scaling. So these application servers have some alarm threshold, okay, like maybe 70% or so, which means that if the utilization goes to 70% or 60%, whatever you have specified, the alarm will be triggered, and then they will ask the auto scaling that the utilization is increasing. What auto scaling will do, it will launch the new resources before the maximum capacity is reached, and the users never experience a service interruption because the new servers were already ready before they reach to the maximum capacity. And when it will not be required, or the CloudWatch will monitor that it is not required, the utilization is less, then also it will tell auto scaling that now you can delete an instance, then it will delete it automatically. So that's a best practice that you should implement. You can use CloudWatch and auto scaling in this case. Then treat the resources as disposable. So what this best practice says, so in a traditional infrastructure environment, you have to work with the fixed resources because of the upfront cost and lead time of introducing new hardware. This drives practices such as manually logging into servers, which the best practice can be to automate, to configure the server, to configure the software or fix issues, hard coding IP addresses, which is there in the traditional infrastructure, which can be replaced with the best practices to switch to new IP addresses automatically, and running tests or processing jobs sequentially, which as a best practice on cloud, we test the updates on new resources and then replace the old resources with the updated ones. So when designing for AWS architectures, you can take advantage of the dynamically provisioned nature of cloud computing. You can think of servers and other components as temporary resources. You can launch as many as you need and use them only for as long as you need them. Make sure you are automating the deployment so that the configurations should remain identical. It should not be like that today you have launched some EC2 instances with some configurations, and tomorrow when you are launching the new ones, they have different configurations. Make sure for the same workload you have whatever resources you are using, you have identical configurations, which can be achieved through the automation. Terminate any resources that are not in use because they can be treated as disposable. Also, do not hard code the IP addresses. Make sure you are switching to IP addresses, the new IP addresses automatically, and test updates on new resources, not on the existing ones. Make sure you are having new resources, test the updates on them. If they are working fine, then replace the old resources with the updated ones. Next best practice comes as the automation. So in a traditional IT infrastructure, you often have to manually react to a variety of events. When deploying on AWS, there's an opportunity for automation so that you improve both of your system's stability and the efficiency of your organization. Consider using one or more types of automation into your application architecture to ensure more resiliency, scalability, and performance. And where possible, automate the provisioning, termination, and configuration of resources. You can use the tools like CloudWatch and EC2 autoscaling to detect any unhealthy resources and automate the launch of replacement resources. So let me give you an example for this. You can see as an NT pattern what is happening here. Here is your instance. So this one, the instance was there which had the application hosted on this. Okay, so this was your application server, and this crashes somehow, maybe due to some reasons, and now the users are not able to access the application. Users will manually notify the administrator, and then administrator manually launches and configures a new server, which again will take some time. But as a best practice, what you can do, here's your server, which is the application server, which due to some reasons has crashed. What is happening here? We are using CloudWatch. It automatically detects any unhealthy instance, which is currently this one. It automatically notifies the administrator that this server has crashed. Also, it automatically launches and configures the identical server. So this notifies auto scaling, and the auto scaling will be launching and configuring the identical server automatically. Okay, user also the administrator also got to know that the server has crashed, but he didn't do anything, like he didn't create the new instance. It was created automatically with the auto scaling. Also, CloudWatch has automatically logged this action, whatever it has done, into a change management solution. Maybe you have implemented some solution like this. So this is quite easy, and this is a best practice in the automation. Then the next practice is the loose coupling. Traditional infrastructure have chains of tightly integrated servers, each with a specific purpose, and the problem is that when one of those components or layers goes down, the disruption to the system can be fatal, and it also impedes the scaling. If you add or remove the servers at one layer, you must also connect every server on each connecting layer. You can see here one example which shows an entry pattern. It has the web servers, 3 web servers and 3 application servers. All of them are tightly coupled. All the servers, each and every server is dependent on every other server. So this is a entry pattern, because if any of the server fails here in the application server, all of them will be affected. All the web servers will be affected. And as a best practice to implement loose coupling, here we are using elastic load balancing. The load balancer will route the request between the web servers and the application servers instead of having to tightly couple them with each other. We have added the load balancer as an intermediate thing. If one application server goes down, the load balancer will automatically start directing all the traffic to 2 healthy servers. It will just stop sending the traffic to the unhealthy instance that is there. So 2 primary solutions for decoupling your components can be: one is the load balancer and another can be message queues. But make sure you are considering loose coupling or decoupling when you are designing your architecture on AWS. Next is design services, not the servers. Let's see what it includes. So first it says use managed services and serverless architectures. Although EC2 instances offers tremendous flexibility for designing and setting up your solution, but it shouldn't always be the first and the only solution that you use for your every need. When appropriate, consider using containers or a serverless solution, because simple applications run on persistent servers, whereas serverless will only run when there's a request. With AWS serverless solutions and managed services, you don't need to provision, configure and manage an entire Amazon EC2 instance. And storing assets on Amazon S3 is a good practice instead of storing them locally on the instances. Also, the user authentication and the user state storage should be handled by managed AWS services instead of letting backend servers handle the user authentication and any user state storage. One such managed service is Amazon Cognito for handling user authentication easily. Next best practice that is here is choosing a right database solution. So what are the things that we need to take care when we go for a database solution? So some questions you need to ask before you choose a database solution for yourself, which can help you make decisions about which solution to include in your architecture, which will help you in getting a good decision. So first is you need to check the read and write needs. Is this a read heavy, write heavy or a balanced workloads? How many reads and writes per second are you going to need? How will those values change if the number of users increases? How much data will you need to store and for how long? How quickly will this grow? Is there any upper limit in the near future? What is the size of each object? How will these objects be accessed? And what are the requirements in terms of durability of data? Is this data store going to be your source of truth Okay, how long you are going to store this, what is the object size, what is the nature of access to these objects, and the latency requirements, how many concurrent users do you need to support, what is your data model, and how are you going to query the data, are your queries relational in nature, could you could you define your schema in a flexible way, or you want a fixed way, what kind of schema do you want. All these things will help you determine the right database solution for your architecture. And next is avoiding single points of failure. Wherever possible, eliminate single points of failure from your architecture. This doesn't mean that you must always duplicate every component. Depending on your downtime service level agreements, you can use automated solutions that only launch the components when needed. So in this example, you can see, just forget that there is no replication. This is just this much, and forget about the replication part for a minute. There will be two application servers which are dependent on this database server. Okay, only one database server is there, no replication. So what if this database server fails? There will be no other option for this application servers to interact with the database. But the another thing is, when we enable the replication, so what happens, you can see the application servers are dependent on the one server, and also the replication is enabled, which is the data is getting replicated to a secondary database server also. So in case when the application server goes down, okay, this primary one has gone offline, so this application servers, they will be starting to point to the secondary server. Instead of failing, instead of just completely going down, they have started pointing to the secondary database server which had the same data. So this kind of replication you can implement as and when and wherever required, not at all the places, but only where required, so that the single point of failure should be avoided. Okay, and next comes the best practice of optimizing of cost. AWS services use a variable expense cost model, which means that you pay only for the individual services that you need for as long as you use them, which is known as pay as you go model. Within each service, you can optimize for cost. Many services offer different pricing tiers, models, or configurations. Ask yourself these questions before you think of the cost optimization. How often will I need to use this resource? Can I replace any of my servers with the managed services? Okay, if like you are going to access something frequently or infrequently, based on that you can save a lot of cost. And if you can go for a managed service, that also will help you in saving cost. How do I make sure to turn off the resources that are not in use? You can automate that, like using auto scaling to reduce the number of instances that are not in use. And are my resources the right size and the type for the job? Are they very big? Are they small? Or what? Make sure they are efficient. And the next best practice is caching. Caching is a technique to make the future requests faster and reduce the network throughput by temporarily storing the data in some intermediate location between the requester and the permanent storage. So just think that if this is not there, if the caching is not there, just forget about this for a moment and think that the requests are directly going to the original location. From the requester to the data, it is directly going, so it will have some kind of latency. In the best practice example that you can see now, the request is not going to the original location all the times. It will instead go to the nearest edge location. Okay, it will go to the edge location where the data is cached, so that now the data can be served to the user in a fast speed. Instead of going to the origin every time, it is serving the data from the edge location itself in order to give the faster response and lower latencies. This reduces the latency, but as well as the cost also, because after the first request, after it has fetched the data from the original location, you no longer pay for the file to be transferred out of Amazon S3, because it will be transferring from CloudFront edge location itself. And then comes the security best practice. The security is not only about getting through the outer boundary of your infrastructure. It also involves ensuring that your individual environments and their components are secured from each other. So make sure you are isolating all the parts of your infrastructure so that the failure of one should not be affecting the another component. Make sure you are encrypting the data in transit and at rest wherever required. Enforce the access control granularly and using the principle of least privilege, granting only the permissions that are genuinely required. Also use MFA wherever possible, okay, which will add a additional layer of login security. And then log all the access of resources, who is accessing what, when they are accessing, from where they are accessing, what they are doing, and automate your deployments to keep the security consistent. Again, in the manual updations, you can make some errors, but consider automating the deployments to make sure the security remains consistent across the environment. And then these were all the best practices that we have discussed. Now the next topic will be well-architected tool. The well-architected tool helps you review the state of your workloads and compares them to the latest architecture best practices. This tool is based on the AWS well-architected framework, which was developed to help cloud architects build secure, high-performing, resilient, and efficient application infrastructure, about which we have already learnt in today's session. To use this free tool available in the AWS console, just define your workload and answer a set of questions regarding operational excellence, security, reliability, performance efficiency, and cost optimization, which are the pillars of well-architected framework. And the well-architected tool will then provide you with the plan on how to architect for cloud using established best practices. So how it works? First, you define the workload. Workload can be simple, such as a static website, or complex, such as microservices architectures with multiple data stores and many components. Then conduct the architectural review. Review your workload against current AWS best practices by answering a set of foundational questions. Then apply the best practices. It will provide you with the list of issues that are found in your workloads and step-by-step guidance to make the improvements. So let me show you how it looks like and how can you define the workload on AWS console. So let's go to AWS console and see how it works. So just search about well-architected tool and click this one, and you will get the option to define your workload. Here just click on define workload and then just give a name to your workload. Let's say I say sample workload, and you can give a description. This is the demo workload. Okay, this you have to give a detailed description or a brief description. You can give for up to 250 characters. And then review owner, you have to give some name or email address or identifier. So I'm just giving ABC. And what is the type of the environment? Is it the production level or the pre-production? So I will say pre-production. The regions in which your workload is existing, you have to select here the AWS regions in which your workload is existing. Let's say I select that it is there in North Virginia, and it was not selected. Okay, and you can also specify if your workload is on another cloud provider or on premises. Here you can specify the account ID. So the IDs of the accounts that your workload spans across, and then architectural design. If you want to give a link to your architectural diagram, you can give that also. Then what kind of industry is this workload being used for, and then you can add the tags also. Then click on next and select what is the lens that you want to select for, so that it will review your architecture based on that. So it is a lens, the well-architected framework, which will provide a set of foundational questions for you to consider all of your cloud architectures. FTR lens, which is a foundational technical review lens, which provides a set of questions to perform a workload self-assessment prior to requesting the foundational technical review in the AWS partner network. Then comes a serverless lens. If you want to get a set of questions to consider for your serverless applications, then software as a service lens, that is a SaaS lens, which you want to consider for your SaaS applications. So for now, I'm just selecting the well architected framework lens, and I say define the workload. Now the workload has been defined. It has been done. Now what I have to do, just click on this and I can answer the questions here. I just need to click on continue reviewing, and you can see here all the questions have appeared. Okay, all the questions in all the pillars, like in the operational excellence, how do you determine what your priorities are? I have to answer this question. And then how do you structure your organization to support the business outcomes? All of these I have to select the options whichever fits to my workload. And then if I scroll down in the security category, I have to answer all these questions. Almost 52 questions are there which I need to answer, and once I save all the answers that I have given, then it will review that and it will provide me with the improvement plan that I can implement to improve my architecture. So this is how you can use a well architected tool. Now let's get back onto the slides and discuss about the another resource and the last topic of today's session, which is AWS Trusted Advisor. Trusted Advisor is an online tool that can provide you recommendations that help you follow AWS best practices. It evaluates your account by using checks, and these checks identify ways to optimize your AWS infrastructure, improve the security and performance, reduce the costs, and monitor service quotas. You can then follow the check recommendations to optimize your services and resources. So how it works, as a customer, you want the most value from your investment. So in this case, Trusted Advisor can help you. Trusted Advisor will scan your entire AWS infrastructure. It compares it to the best practices in the 5 categories that you can see here: cost optimization, performance, security, fault tolerance, service limits. It will tell you if you are approaching any limits of any service or something like whatever services, soft limits or whatever are there. It will keep you posted on that also, and it then gives you the recommendation and action links. So what are these symbols meaning? Let me tell you. Let's say you open the Trusted Advisor on the AWS console. Currently, if I go to my AWS console and check, it won't be much there. So let me see. I need to update the plan in order to get a full set of checks, but we can see what it is giving us currently. So this is what it is saying. As a summary, it is saying that there are no actions recommended, but one is investigation is recommended. And you can see in all the categories, in the service limits, in fault tolerance, everything, it will give all the actions, any best practices, whatever is there, it will tell me. Okay, so you can check for all the categories that are there, and you can improve, you can make the changes according to the advices that it is giving you. Okay, like the auto scaling group for any kind of auto scaling configuration, for EBS snapshots and anything, all these categories you can check in your account, and you can make sure you can make the improvements accordingly. Okay, and not all the checks will be available, because you will need to upgrade your support plan to a higher one if you need all the checks, but the basic checks, few will be available in your console. Okay, so what does this mean? The red one, this means action recommended. It means the Trusted Advisor recommends an action for the check. Then the yellow one, the investigation recommended, means it detects a possible issue for the check and no problems detected. Green one means that Trusted Advisor doesn't detect an issue for the check. Then gray one means the excluded items. It says the number of checks that have excluded items, such as resources that you want to check to ignore. Okay, so this is how the Trusted Advisor looks like and works. So this is all about the architecting, the concepts, the best practices and the services that are involved, the tool that is involved. So I hope you have understood all of them, and from next time when you are designing a architecture on AWS, you will be following all the best practices. So we will meet in the next video. Thank you.